Hi, everyone. Let's continue with section 2.4, frequency distribution tables. This is the last example that I did with you, example 3. In the last video, I introduced what a frequency distribution table looks like. And I explained that a lot of times when we have a data set, it's nice to summarize the data set in a table that looks like this, where we break the data into classes that all have the same width. And then what we do is we list the count or the frequency. So how many times does a data value occur within each class, right? So for example, the class 7 to 18, we had 6 data values that were between 7 and 18 and so on and so forth. I went over class mark, which is the midpoint of the class. And then I also talked about relative frequency, which is just rewriting the count or the frequency as a decimal or a percent. So it's a proportion. So let's move on to example 4. Example 4 says the following data set represents the weights in kilograms of 31 grizzly bears that were tracked in North America. So here are the weights of the grizzly bears. Weights are measured in kilograms. This is one data set. I listed it in 3 different columns just because it was easier to fit on the page. But this is one data set. So there's 31 data values here. And this is an example of continuous data, right? So in 2 lessons ago, 2 previous videos, I talked about the different types of data. And whenever we have a measurement, right? So whenever we're going to take a measurement, in this case, weight, we're going to consider it a continuous variable. So what I want to do is let's summarize or organize this data set into a nice frequency table. So part A is asking us to create a frequency table, and I want to use 7 classes. So in other words, let's break our data set into 7 weight classes. Now, in order to create the classes, and I'm going to put the classes in the first column, we have to know where to begin, right? So what's going to be my first lower class limit? The rule of thumb is always start your first class with the minimum data value in the set. So this set isn't in order, right? It's raw data, but if we kind of scan and look through these weights, we could see that 98 is the minimum weight in the data set. And we might as well look for the maximum weight also. So if we scan, we could see that 359 is the maximum data value in this set. So the rule of thumb is to start your first class with the minimum data value in the set. So in this case, that's going to be 98. Now, remember in the previous video, in the previous example, example 3, when I introduced that frequency table, we had a class width, right? So let me go back and let's just look at this example. So remember, we determined in this example that the class width was 12, right? Because 12 is the difference between each lower class limit, consecutive lower class limit, right? 7 to 19 is 12, 19 to 31 is 12, and so on and so forth. But now we have to figure out what the width should be in the example that we're looking at, because we want these classes, these weight classes, to all be the same size. So we want these intervals to be uniform. So we have a formula for class width. So whenever we have a raw data set and we want to calculate the class width, and I have, just so you know, right above this example, I have all the steps or procedure for constructing a frequency distribution table. So the first thing we do is we decide on the number of classes. I'm going to tell you how many classes to use. And when you do the homework questions, they're also going to tell you how many classes to use. But typically, we use anywhere from 5 to 15 classes. The smaller the data set, the less classes we would need. The larger the data set, we would use more classes. But typically anywhere between 5 and 15. So for this particular example, I said to use 7 classes. So we said, okay, we're going to start the first class with the minimum data value in the set. Now we have to determine the width. We want to know how wide the classes should be. So in order to determine the class width, we take the largest data value minus the smallest data value, and we divide by the number of classes. And then we're always going to round up. So we're going to round our answer, because typically we're going to get a decimal number. We're going to round our answer to the next whole number. So let's use this formula to calculate the class width for this example. So we take the maximum data value in the set minus the minimum data value in the set, and we divide by the number of desired classes, which in this case is 7. So we're going to take the max, which is 359. We're going to subtract the minimum data value, which is 98. And then we're going to divide by 7 because we're using 7 classes. And we could do this together on the calculator. So if I share my calculator screen, I'm going to take 359 minus 98. Now, it's very important that if you're going to plug this calculation in one step, you have to have parentheses around the numerator due to order of operations. Now, once we take the difference, we divide by 7, and we're going to get 37, about 37.29 if we go 2 decimal places. And the rule is we're going to round up. So 38 is going to be the class width. Now remember back to the previous example, the class width is the difference between each consecutive lower class boundary. So if my first class, the lower limit is 98, if I add the class width to that, that's going to give me the next lower limit. So we're going to take 98 and we're going to add the width of 38. And we could do that together on the calculator. So 98 plus 38 is going to be 136. So we're going to begin our next class at 136. So that difference is the class width, which is 38. Now to get the lower class limit on the next class, we're going to add 38 again. So we're going to keep adding 38, which is the class width, to every lower limit. So we'll do it one more time together, and then I'll fill in the rest of them for us. So now we're going to take 136, we're going to add 38 again, and we're going to get 174. So we're going to begin the next class at 174. So I'm going to do the rest for us. So if we keep adding 38, my next lower limit's going to be 212. If I add 38 again, we're going to get 250. If I add 38 again, we're going to get 288. And then if I add 38 one more time, I'm going to get 326. Now let's figure out what our upper class limit should be. So the first class starts at 98. The second class starts at 136. So the rule of thumb is to stop each previous class. So in other words, the upper class limit should be 1 less than the next lower class limit. So for example, 98 is going to go to 135 because that's 1 less than 136. The next class starts at 136. Now the next class starts at 174, so we're going to stop 1 less than 174, which is going to be 173, and so on and so forth. So the next class is going to go from 174 to 211. The next class is going to go from 212 to 249. The next class is going to go from 250 to 287. The next class is going to go from 288 to 325. And then this one's just a little tricky because you don't have a next class to base it on. So we just have to keep in mind the class width is 38, right? So the difference between all our lower class limits is 38, but the difference between all our upper class limits should also be 38. Right? So from 135 to 173, the difference is 38. From 173 to 211, the difference is 38, all the way down. So in order to get that last upper limit, take the previous upper limit, which is 325, and we're going to add 38. So if I take 325 and I add 38, I'm going to get 363. So those are my 7 weight classes. So we just divided our data set up into 7 weight classes. Now what we're going to do is we're going to count. That's the frequency column, just like we looked at in the previous example that we did, that frequency table that I gave you, it had a frequency. And remember, that's just how many data values are in each class. So you could think of frequency as count. So now what we have to do is let's look at our data set, and we want to count how many data values are within each class. Now this is raw, this data set. It's not in order, so it's going to be kind of hard to kind of look through this data set and try to figure out, okay, how many weights are between 98 and 135? How many weights are between 136 and 173? So the easiest way to do this is to enter this list into the calculator and sort it. And remember, in the previous video that I did for you guys, I showed you how to enter a list into the calculator and sort it. So what I'm going to have you do is right now, if you have to, I want you to pause this video and I want you to enter this list into the calculator and I want you to sort it. And I'm going to pull up my calculator, and I already entered this list into the calculator and I already sorted it. And just a quick reminder, I'll go over the steps, but I'm not going to enter this whole, list with you just because it's time consuming. And I know you guys could do this on your own because I already showed you how to do it. So remember, whenever you want to enter a list of data into the calculator, you press stat and then edit, which is option 1. And then now you have access to all your lists. I put the bear data in list 2, and then I sorted it. So remember, just key in all the data values. You should have 31. You could choose whichever list you want. Like I said, I'm using L2. And then remember to sort it, you're going to press stat again. And now you're going to sort A for ascending order. And you're going to tell the calculator what list you want it to sort. Mine was L2. So remember, each of these keys, 1, 2, 3, 4, 5, and 6, above and in blue, have a list associated with it. So L2 is above the number 2 key. So I'm going to press second and then 2, and it's going to pull up L2. I press enter, and it's done. And now if I want to see my sorted list, I go back to stat and edit. And now I could see my list is in order from 98 all the way down to the max, which was 359. So if you need to pause and enter your list into the calculator, do so now. So everybody should have their list in the calculator. It should be sorted. So what we're going to do now is we're going to go back to the calculator and we're going to count the frequency. So how many data values are between 98 and 135? So let's do that together. So go to your sorted list. And just let's arrow down and count. So let's count how many data values are between 98 and 135. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it, because 144 is too high, right? That doesn't fall between 98 and 135. So 10. So these first 10 data values are between 98 and 135. So my frequency for the first class is going to be 10, because there's 10 weights between 98 and 135 kilograms. Now we're going to do the same thing for the rest of the classes. Let's count how many weights are between 136 and 173. So we'll start at 144, and we don't want to go past 173. So we have 1, 2, 3, 4, 5, 6, 7. So 7. And we're going to continue in that manner. So I want you to keep counting how many data values fall within each class. So from 174 to 211, you should get 6 data values. From 212 to 249, we're going to get 3 data values. From 250 to 287, we're going to get 3 data values. From 288 to 325, there should be 1. And then from 326 to 363, there should also be 1. So that's what your frequency should look like. I also want to point out that you can check to make sure that your frequency column makes sense, because think about it. There were 31 data values in the set, right? And each one of them is going to fall into a class. So your frequency column should add up to the total number of data values that are in your set, which in this case is 31, right? So 10 plus 7 plus 6 plus 3 plus 3 plus 1 plus 1 is 31. So that checks out. So we didn't miss any. Now let's calculate the class mark. Remember, the class mark is the midpoint of your class. So the way we get the class mark, and we could look at the steps above, every step that we do for these frequency tables, I have up here in the procedures. So we already constructed the class boundaries. Now we're up to determining the class mark. So we take the upper limit plus the lower limit, and we divide by 2. So let's calculate the class mark for that first class. So for 98 to 135, what we're going to do is we're going to take 98 plus 135, and we're going to divide by 2. And that's going to give us 116.5. So that's going to be my first class mark, 116.5. That's the number right smack in the middle between 98 and 135. So if I want to get the class mark for my second class, I'm going to take the lower limit plus the upper limit. So 136 plus 173, and I'm going to divide by 2. And I'm going to get 154.5. So 154.5 is going to be the class mark for the second class. Now, let me mention a shortcut. You don't have to make this calculation for every single class. You can if you want, but there's a pattern here. The class width is 38, right? Between each consecutive lower limit and every consecutive upper limit, the difference is 38. So the difference also going to be 38 for all your class marks too. Like look at 116.5 plus 38 is 154.5. So if you want to take 154.5 and add 38, you're going to get 192.5. If we add 38 to 192.5, I'm going to get 230.5, and so on and so forth. So we could keep adding 38. So we're going to get 268.5. If I add 38 to that, my next class mark is going to be 306.5. And then if I add 38 to that, I'm going to get 344.5 for my last class mark, which is just the midpoint of the class. Now, sometimes when we create a frequency table, we also like to calculate the relative frequency. And remember the relative frequency I showed you in the example that we did in the last video. The relative frequency is just the frequency divided by the total number of data values. So it's giving us the frequency, but as a proportion or a percent. And remember, I showed you guys how to convert to percent in that last video. So for example, if I want the relative frequency for this first class, I'm going to take the frequency, which is 10, and I'm going to divide it by the total number of observations or data values, which is 31. And let's round 2 places. So we'll do the first one together. If I take 10 and I divide by 31, if I round 2 places, that's about 0.32. So the first relative frequency is 0.32. The next relative frequency is going to be 7 out of 31. And if we plug that in the calculator, we're going to get about 0.23 if we go 2 places. The next relative frequency is going to be the frequency 6 out of 31, and that's going to be 0.19. The next relative frequency is going to be 3 out of 31, which is about 0.10. The next one's going to be the same, 3 out of 31, which is 0.10. And then the last two are going to be 1 out of 31, which is about 0.03. So that's how we can look at these frequencies instead of counts as relative frequencies, which are proportions. So I want to point out this relative frequency column should always sum up to 1 or 100% if we were converting these to percentages, which makes sense, right? Because 10 out of 31 plus 7 out of 31, if you were to add all these up, it's going to be 31 out of 31 or 1. Now, this last column in our frequency table is called class boundaries. Now, we only use class boundaries if we're working with continuous data. And in this case, we are working with continuous data, right? We're working with weights of grizzly bears, and weight is continuous. So we're going to include class boundaries. So class boundaries are only for continuous data. And you'll see why in a minute. So to get the class boundaries, what we do is, and I have the steps up here in case you want to refer to it when you're practicing on your own. So this is step 5. So if you want to determine the class boundaries for continuous data, what you're going to do is you're going to subtract 1/2 from each lower class limit, and you're going to add 1/2 to each upper class limit. So let me show you. So the first class goes from 98 to 135. The lower limit is 98, so we subtract 1/2 from the lower limit. So 98 minus 1/2 is going to be 97.5. And then we add 1/2 to the upper limit. So we're going to add it to 135. So that's going to be 135.5. Let's do the same thing for the next class. 136 to 173. Take the lower limit, 136, subtract 1/2. So we're going to get 135.5. And then add 1/2 to the upper limit of 173. So we're going to get 173.5. The next limit, or class, I should say, is 174 to 211. Subtract 1/2 from the lower limit, so from 174, so that's going to be 173.5. And then add the 1/2 to 211. So 211 plus 1/2 is going to be 211.5. And I want you to see what happens. You see, when we write the class boundaries, there's no gaps in between these intervals. We go from 97.5 to 135.5, but then the next class starts at 135.5 and goes to 173.5. And then the next class starts at 173.5, and so on and so forth. So this makes sense for continuous data because the data is continuous. There should be no gaps in between these boundaries. So let's continue. So the next one is going to go from 211.5 to 249.5. Let's fix that 5. Then we're going to go from 249.5 to 287.5. We're going to go from 287.5 to 325.5. And then last, we're going to go from 325.5. I don't like that 3. Let's fix that up. To 363.5. And these class boundaries, like I said, are useful for continuous data, specifically for constructing a histogram, which is a graph that's going to represent this frequency table. So I'll continue this in the next video. So we'll stop here. We'll do part B in the next video, constructing a frequency histogram using the table that we just created. And before we end this video, I just want to kind of sum everything up and say, what we just did was we took this raw data set, right? All these weights of these grizzly bears, which was raw data. It was not organized, it wasn't in order. It's just this mess of data values on the paper, right? We're just staring at a raw data set of 31 weights. We just organized these bears' weights into a nice table and we divided it into 7 weight classes. And we could kind of start to now see what this data set looks like, right? Look at where most of the frequencies are. Most of the frequencies are in the first 3 classes, right? 10 plus 7 plus 6 is 23. So more than half of the weights are in these lower weight classes. And look what happens as the weight classes get higher. There's less bears, right, that are in these, or weights that are in these higher weight classes. So, but we weren't able to tell that when we were just looking at that raw data set, right? We weren't able to say, oh, bears tend to weigh on the lower end rather than in the higher weight classes, right? But now that we organize this data, we can start to say, you know what, it looks like these bears overall tend to be in the lower weight classes. There's not as many bears that fall, in the heavier weight classes. So we'll see this even further when we construct the histogram and then we start talking about shape in the next video.